All right, let's talk about the internet. For decades, there's been this fundamental piece missing, a ghost in the machine. See, we can move information around the globe in an instant, but we've never been able to move value with that same ease. Today, we're diving into the protocol that's finally waking that ghost up to fix the internet's original sin. Okay, let's get into it.
It all boils down to this one simple, almost ridiculous question. Why can't your software just pay for things? Seriously, why can't an AI agent pay for its own data? Or a simple script pay for an API call without a human having to step in, pull out a credit card, and set up some clunky subscription? This is the core problem we're going to unpack.
And the reason is literally baked right into the web's DNA. The internet's original rulebook, things like HTTP, it was all designed to move information, text, images, you name it, freely and globally. But a native way to move value? Nope, it was just left out. So we had to bolt on our entire financial system afterwards, which created all this friction, these high fees, and business models that frankly just don't make sense anymore.
And this slide, this really just lays it all out. Look at the x402 protocol. Settlement? We're talking 2 seconds on what's called a layer 2 network. Think of it as a super fast express lane for the blockchain. Now compare that to traditional systems where you're waiting days. The fees make tiny transactions completely pointless, and merchants are always worried about chargebacks. Now that's fine if you're buying a sweater, but for a high-speed machine economy where AIs might need to make millions of tiny payments a day, it's a total non-starter.
So how do we fix this? Well, what's so cool is that the solution isn't to build some brand new thing from scratch. It's to activate a piece of the internet that's been hiding in plain sight, just lying dormant for over 20 years.
Say hello to HTTP 402, payment required. You've definitely seen 404 not found, right? Well, 402 was created by the web's pioneers with some incredible foresight. They literally reserved this code for a future where a server could just ask a client for payment, natively. But for decades, it was nothing more than a placeholder, a digital ghost in the internet's blueprints.
Until now, the x402 protocol is the key that finally turns this code on. It's an open standard that makes payment required as natural a part of a web conversation as OK or not found. It weaves value exchange right into the internet's grammar by handling payments on-chain, which is just a fancy way of saying each transaction is final, public, and recorded on a blockchain. This finally plugs that huge hole in the internet's architecture.
Okay, so how does this actually work in the real world? It's surprisingly simple. Think of it like an elegant 3-player handshake that happens right on top of the web we already use every day. So first, you've got the 3 main roles in this little dance. There's the client, that's the buyer, which could be you, a script, or an AI. Then there's the resource server, that's the seller. And then you've got this optional player, the facilitator. Now, this is a strategic masterstroke because this is the guy who handles all the messy blockchain stuff, which makes it incredibly easy for any developer to start using x402 without having to become some kind of crypto genius. And here's the handshake. The client asks for something, the server replies, "Whoa, hold on, 402, you need to pay," and it attaches a digital invoice. The client's wallet automatically signs the payment, and then, and this is the cool part, the client sends the exact same request again, but this time with proof of payments attached. The server verifies it, hands over the goods, and gets the money. It's all a seamless little conversation happening inside a totally standard web request. And this simple, elegant flow, well, this is what changes absolutely everything. Because this process is so ridiculously efficient, it makes tiny, fractional payments, micropayments, not just possible, but profitable for the very first time.
Just look at that number, less than 1/10 of a cent. That's what a typical transaction costs. When the fee to send money is practically zero, it completely rewrites the rules of what you can sell online. The entire economic model of the internet gets a massive upgrade.
All of a sudden, you can have true pay-per-use for pretty much everything. Instead of that monthly subscription, what if you paid just a few cents for the one article you actually want to read? An AI agent could pay a fraction of a cent for a single piece of data, or for the exact amount of cloud computing it needs. This just unlocks a whole new digital economy that was literally impossible before. But, and there's always a but, this incredible new power comes with a really critical trade-off. To be this fast and this cheap, the protocol depends on the finality of blockchain payments, and that creates something we can call the great risk inversion. This quote just nails it. Here's what it really means. With your credit card, if a merchant scams you, you call the bank and you issue a chargeback. The risk is on the merchant. With x402, payments are final, irreversible.
Now that's amazing for merchants. Poof, no more chargeback fraud. But it means the risk flips over to you, the consumer. If you accidentally pay a fraudulent server, there's no built-in way to get that money back.
So let's just quickly recap the good stuff. You're unlocking these incredible pay-per-use models, you're slashing costs for merchants, and you're building the financial plumbing for a real AI economy, all on an open standard that means no single company can ever control it.
But on the flip side, the challenges are very real. You've got that consumer protection gap, the ongoing headache of making crypto wallets easy enough for your grandma to use, a bunch of regulatory question marks, and of course the classic chicken and egg problem. You need buyers for the sellers to show up and sellers for the buyers to show up.
So, overcoming these challenges, it takes more than just slick code. It takes an ecosystem. And this is where the story gets really interesting, because a powerhouse coalition is forming to turn x402 into a core piece of our internet infrastructure.
Right at the center of it all is the x402 Foundation. Now, by putting the protocol in a neutral, non-profit foundation, Coinbase and Cloudflare are making a huge statement. They're ensuring this thing develops as a true public good, an open standard for everyone, not some proprietary product they control. That builds trust.
Cloudflare's involvement here is absolutely massive. I mean, by building x402 right into their gigantic global network, they're creating an incredible distribution channel. They're basically hitting the turbo button on adoption and getting this tool into the hands of millions of developers almost overnight.
And then you've got Google. This is a huge vote of confidence. They're not trying to compete with x402, they're embracing it. Google is building a bigger framework for AI agents, and they've positioned x402 as the default settlement rail. Think of it as the underlying pipes for those agents to make payments using stablecoins, which are just digital dollars.
And it's not just the tech giants. Even Visa is getting in on this, working to make their systems talk to x420. This just goes to show that the goal isn't to tear down the old financial world, but to build a bridge to it, to combine the best of the old and the new.
Which brings us right back to the big picture. The first version of the web, it connected information. It gave us knowledge at our fingertips. The next version connected people, and it gave us social media. The question that x402 is forcing all of us to ask is, what happens when we finally, natively connect value? What new economies, what new services, what new forms of autonomous software will emerge when money can move as freely as a single bit of data? It's a big question. Thanks for watching.